There is a world coming in which you can demonstrate a task in a video or drive the end effectors of a robot, and that turns into capability. And all of a sudden, my factory worker is now my programmer. And I think that's a super exciting concept, and we're right at the forefront of that as an industry.
The world is increasingly automated, and a big part of that is the robotics behind the scenes. So in the AI era, how is the world of robotics changing? And where are we heading with the future of automation in industrial environments? We're here with the perfect person to discuss it, Aaron Saunders, the Chief Technology Officer for Boston Dynamics. Aaron, welcome to AI in Action. So you've been working on the forefront of robotics technology for a tremendously long time. Big picture before we dive in. How far away are we from Rosie the robot from the Jetsons showing up at our front door to clean up?
Oh, that's such a good question. I get it asked a lot. I think it really depends on what you mean when you say Rosie. So maybe I'll give you a quick answer now, but I think by the time we're done today, we'll have filled in a lot of pieces. So I think we'll see a lot of robots enter our home that will be purpose-built. But when I think of Rosie, I think of a robot that can do anything, that can operate from the entertainment to the cleaning end of the spectrum, that can figure out any problem. And I think a robot like that would also need to be incredibly safe. It would have to be inexpensive, and it would have to be able to do anything that I wanted to do. And in that framework, I think we're a long ways away from Rosie. But I do think we're going to see robots in our homes and in our factories a lot sooner than we get the full Rosie experience.
Which ones do you think is further away, the safety or the expense?
I think safety is probably one of the bigger challenges. And the reason I say that is because safety isn't just about the robot itself. It's about what it's doing. So if you want a robot that can lift and clean and do useful work in your environment, the safety is not only the robot, but it's all the things the robot's interacting with. And I think it's a complicated problem. I think the hardware and the software costs are probably going to be easier to solve than the larger topic of safety.
So we started from machine learning, then traditional AI, and now we're in this generative AI and agentic AI era. How has the field of robotics started to shift from this deterministic to open-ended technology?
I would describe the shifts as tectonic. You know, they're not these like little gradual things. We saw a pretty big shift back when we moved from traditional computer vision to machine learning. And it wasn't too long ago that we were having the same conversations about replacing computer vision algorithm with a machine learning technique. And here we are again, bringing in large language models, foundation models, and they really are changing almost all aspects of how we're approaching programming robots. And that goes from how you interface with a robot through how a robot controls its body. So I think we're seeing the general and rapid progress in AI touch almost all the parts of the robot stack in a pretty exciting and fundamental way.
With generative AI able to answer open-ended questions, how can robots change with that technology?
The open-ended nature of the question is maybe not the most important topic in robotics. It's how the robot acts after it's taken that input, right? So I think the input side could be quite open. Having a conversation with a robot or having a robot make a call to a visual foundation model to get some information back. The question is, how does it take that information and create action? And in that action space, I think there's a lot of uncertainty. I think there's a lot of stuff that we're developing now. So we're in an era where you're seeing examples and demonstrations of all sorts of amazing things. I think there's work to do to get from those demonstrations to something that you really can quantify, qualify, deliver in a way to a customer that you can predict the outcome of those technologies. So I think, you know, maybe on the input side, there's a lot of exciting ways we can take an open-ended interaction with a robot. On the output side, we still have a lot of work to do to make the actions of the robot be predictable and be reliable and be safe.
Yeah, I feel like there's going to be a ton of guardrails that you have to put on, especially with the way generative AI models respond and do things now. You probably have a lot of guardrails because I imagine you can't deliver something like, okay, this is going to work 99% of the time, but 1% of the time it's not going to do what you're expecting.
Yeah, 99 is not good enough. I think that's a hard thing for roboticists to confront that are on the research or early stage development side. When you deploy a robot, customers aren't okay with 90% or 95%. The other thing that maybe would be a useful concept to unpack here, a lot of people think of AI as a thing, right? A single model that takes that input that you're talking about and commands the output. And although I think there's a future in which there's a single model that does everything, a single model that goes from language input to action output, or a lot of people talk about vision language action models. I think there's a future in which there's a model that could do all of this, but remember, there's other ways to do things. So I think maybe the way that you could start thinking about pulling some of these guardrails in is that you could have an AI model that still, the output of that model still has to go through another stage in your system. And that stage can do smart things. And that stage could be deterministic. That stage could be made with a technology that you can predict and you can qualify. So I think if you think of AI as a bunch of building blocks, and those building blocks can be connected to other types of building blocks, you start to see how we're going to take this new technology and map it into an industrial or home setting where you really need to have predictability and quantified results.
Do you think that there's a future where we can get using these big general AI models eventually when we get there? Do you think there's a future where you could have 100% reliability?
Again, at a systems level, maybe. One of the questions that we get asked all the time is, what's the accuracy of a prediction? We deploy a new foundation model, and we may only be seeing 60 to 80% accuracy in terms of her prediction, but let's back up to before we had that. So I'll talk a little bit about the way maybe quadrupeds look at the world and navigate to kind of anchor this example. If I go back a few years, mostly how these robots navigated is they built height maps around them. So they kind of built a little map around the robot, and it was very simple. Can I step on that or not? If I can't step on it, how do I avoid it, right? They were very simple rules. And so that meant really robust locomotion, right? I could walk down a hallway. I could avoid bumping into a person. I knew how to walk through a narrow doorway. And so we got that very reliable. Now I can add to that one of these less reliable models that starts to give me information and context. And we might call this context-aware navigation. So for example, now in that same hallway, there might be a pile of wires, or in a video that I showed recently, a ladder or a cart. AI can start to help me understand that there are objects in this environment that I might not want to step on or bump into. And so if I combine that robust layer, where I was doing a very good job not making contact with the world, with a layer that's giving me more information, I could be more intelligent while still having that predictable and reliable capability of not bumping into things.
General understanding of robotics currently, for at least the general population, we imagine, automated robots in warehouses shipping us our packages. But what are some of the other use cases for AI-powered robots that businesses should really consider as like a possible avenue to create cost savings and operational efficiency?
Yeah, I think a lot of the ways that we're thinking of robotics now is really on the industrial side of the spectrum. So if you think about warehouses and factories and construction sites, these are places where large amounts of physical labor are being done all the time. A lot of times these jobs are dangerous, they're monotonous, they're things that aren't taking great advantage of the skills of a human. And we can put robots into these environments and have them work alongside or with the human workforce to kind of increase productivity. So I think, in the short term, the places that we're looking are really in industrial sectors. They're places where you have a large operation that's doing something very repetitively, and you're trying to figure out how to take automation and really get past the current state of automation and into some of these areas that have been traditionally hard to automate.
So sticking with like industrial environments, is there any kind of robotics or robots that work with safety?
I think we talked about safety from the perspective of, is a robot safe? But actually there's the other side of it, which is how can robots help us make our work environment safer? We have robots that are walking around some of the nuclear disaster sites in the world and going further into those sites than anybody has been to date. And by doing that, they're providing information that lets us decide, can we send human workforce in? How do we go about planning the decommissioning or the cleanup? And that's an example of sending a robot into a situation that's incredibly hazardous so that you don't have to send your human workforce in. So these are just some examples where I think safety can show up on the value side of a robot, not just the technical stack side of a robot.
So for a robot that you sent into someplace like Fukushima or wherever that there was a nuclear disaster, what is the process after the robot comes out? Like, is there a cleaning process? Do you decommission it? Or is there a cost for the actual robot itself?
This is a really interesting one. So just to be clear, we didn't design our robots to go into a high nuclear environment. We're putting them in there because there's a need for a highly mobile robot, and we have an incredibly mobile and reliable robot. So our intent when we went into these environments was to never get the robot. In fact, we said, please never send us the robot back, right? It was always a joke in the technician side of our business. I never want to see this robot back. If it breaks, just bury it. What we found when we deployed these robots, so essentially what happens when we deploy robots in places like this is the intent is it's a one-way trip for the robot. They usually go into a place where you can interact with them with the right protective clothing. You might be able to do some decontamination, but effectively, they live in a small vestibule that you can enter one side of, and then they leave the other side and they go into the facility. So we do have to do a lot of things that with our partners, in fact, that help us interact with these pieces of equipment. But even if you were consuming these robots, and many of these robots have been doing this kind of work for years, even if you consume these robots over months or years, you have to compare that to consuming the human in the same environment, because often people that go in to install a single camera or a single Wi-Fi repeater receive a year's dose, and then they have to go somewhere else and do something else. And so I really think even if you were consuming this technology, it's still an amazing thing to do. This is why robots exist, essentially, to be consumed so that we're not consuming ourselves in these same jobs.
Let's go back to this idea of 100% reliability. How do you approach your asset stack knowing that your machines need to never, ever mess up? How do you do that practically?
Practically speaking, when you develop your products, you have to have a really good V&V method, a method to kind of verify what you're doing. So at Boston Dynamics, what we learned early is that before your customers, walked a kilometer with their robot, you need to walk 1,000 in your test facility. So inside of our building, we have hundreds of robots that are continuously testing and continuously exploring how our new features regress into existing applications. We even have a few robots that every single time you build code, they stand up, they do some stuff, and they sit down, and hardware in the loop testing, which is not a novel concept. It's a concept that's existed in automotive, for example, for a long time. But really, the first way we approach it is test, test, test. And you really have to put a lot of hours. And for us, what's interesting is those hours have to be in all of the environments our customers are in. So we have robots that stomp around outside in a pen in the middle of a storm in a Massachusetts winter, because some of our customers are working in the snow. So it's really about testing and not being shy to kind of try to break your product, try to make it fail and learn from that and feed that back into your development process.
Have you ever seen AI-enhanced robotics directly impact return on investment for organizations, whether through cost savings, asset longevity, reduced downtime?
Oh, for sure. Yeah. So I think one of the biggest growths of value right now in our product is all of the beautiful, I'll call them little models that we can build on top of our product. So, really simple examples. One of our customers just wanted to be able to count bins in their facility or verify that bins were in the right place. Another customer wanted to listen for an acoustic signature in a rotating piece of equipment to try to figure out where bearing life might be headed. All these little things are things that you can do with AI models because they're things where you're essentially leveraging data, lots of samples of a measurement in order to extract patterns or trends. So I think anywhere where you can leverage that pipeline of data driving a model, that essentially drives value for a customer. And there's an almost endless number of those little things that you can do once you have a piece of equipment that you can move around the world.
Are there any cultural or organizational or operational changes that are necessary in asset-intensive industries if they want to really unlock the true potential of AI?
Maybe I'll kind of go at some of the challenges we face in deploying this technology, because I think we have a lot of technology as a community that we're ready to start testing. But one of the challenges is the customer willing to test it or wanting to. And here's a very specific example. In order to use these new AI techniques or these data-driven methods, you need to be operating on pictures and images, and those have to come from a facility. That facility might have people, it might have equipment, sensitive IP in it. So the question that we always wrestle with is, how do we work with our customer to access the data we need to build and tune and deliver this AI while maintaining privacy, both for the people involved, but also for the company. So we spend a lot of time building systems and working with our customers to very carefully manage their data and to deploy that in a responsible way. But I think as an industry, one of the big challenges is you need a lot of data from the customer and the facility in order to build these AI techniques. And I think the method at which that data gets transferred to technologists is not clear. So if I'm a big company and I'm interested in a small startup's new product, am I comfortable sharing a year's worth of images out of my facility? And if I'm not, how do I help them build the pieces that they need to build in order to build these technologies? So I think there's a lot of stuff on the data privacy, and data management end of the spectrum that we as an industry and both on the customer and the technology side need to figure out.
So is there anything that you're expecting that maybe the general public is not expecting in terms of like AI and robotics in the future?
Oh, let's see. There's maybe two sides of that. There's the positive side and there's the
Yes.
negative side.
Positive first.
I think these technologies are going to significantly reduce the barrier for people to interact with robots, whether it's through an LLM and natural language, you're talking to a robot, not writing lines of code, or some other method that maybe makes it more easier for the general population to engage and interact with robots. So I think that's the thing that's probably going to surprise people the most. On the negative side, I think these technologies are amazing at demonstrating potential, but we have a lot of work, as you pointed out right at the beginning, going from 70 to 80 to 99 to 99.999997. That's a huge challenge for us, right? So I think on the other side, maybe on the side where we have to do expectation management, we may be able to show the potential of one of these technologies quickly, and it might be very, very exciting. But that doesn't mean that there isn't a huge amount of work to get between that initial stage and something that you're really depending on, really trusting, really, something that is operationalized in your business.
So an ideal future for you would be what? What are you expecting from, or what are you hoping from the future of robotics?
I think the velocity that the community is generated in the last few years is the most exciting thing. So I think it's less about whether we're there or not, or when will we have Rosie. It's how do we preserve the inertia of the community? There's so much progress right now that we are moving towards that future. So I think it's really about preserving the speed at which we're marching into that future. It's less about when will I get to the future, and it's more about how fast are we moving in the right direction?
Once these tools are available at like a reasonable price, and then you have like an open source community of engineers working with those robots, imagine like where that can possibly go, right? That's really exciting to think about for me.
Just kind of playing off that a little bit, we're already seeing evidence of this cycle right now. So if you go back 5 to 10 years, there was a very small number of people making robots out in the real world, outside of our buildings, off of a pedestal, truly mobile robots. Some of the most exciting examples were vacuum cleaners, not too long ago. I think we're seeing the era of the robotic startup right now. It may not be completely in the open source community yet, but you're seeing startup after startup starting and within a year or two having really interesting, compelling results. Why is that? Well, that's because we've commoditized so much stuff already. And when you combine the commoditization of all the core technologies and you add in all of the progress in AI, we're in that phase now. We're in that phase where you can start a small business and you can make a robot and you can make that robot do something impressive and you can make that robot demonstrate commercial value. And so I think we're at the very start of this massive acceleration of progress, because it's no longer just a few academic labs or a few very talented small groups of people. It's now become this amazing frothy space of startups and exciting energy and money and investment. So I think we're seeing it right now.
Is there anything else you want to say to other CTOs about robotics and AI? Anything they need to know today to make their business better tomorrow?
I'm going to try to answer this in a couple of ways. One is maybe advice to other CTOs, very specifically, because that was in your question. I think one of the most important things for CTOs in this space is to think deeply about the difference between showing their customer something that has potential and delivering them something that they can use. So I think everybody has to really remember that if the end state is a product, then you're really starting from the needs of your customer, and the goal is to satisfy those needs. And you have to be really careful how you set expectations and how you set the journey with them, because it's really easy to have a disconnect in expectations. And for most of the people in this community, the difference between success and failure is less about whether they fixed all the problems on day one and more about whether they've entered a relationship with a customer that has the ability to kind of survive all of the uncertainty. So I think focus on honesty and transparency, and focus on the relationship with your customer, because it's not going to be easy and it's not going to be linear. And I think that's how you get through all of this uncertainty. So that's my advice to maybe the CTO. And then, in terms of a thought that I wanted to maybe end with, going back to your Rosie the robot question, I think we're truly in this place where we are moving the way in which you program a robot from lines of code, which is something that was only accessible to experts in particular fields, to a place where we're programming robots with data. And that data could be a demonstration. And the reason why that's really exciting is because the people that are the experts in the world could become the robot programmers in that new model. And so what I'm most excited about is that there is a world coming which you can demonstrate a task in a video or drive the end effectors of a robot and capture the data. And that turns into capability. And all of a sudden, my factory worker is now my programmer, not only the people that know how to write code. And I think that's a super exciting concept. And we're right at the forefront of that as an industry.
Aaron, thank you so much for this. I really, really love this conversation. Thank you so much for giving us your time. To all of you, thanks for listening. And are you subscribed yet? Make sure you follow us on YouTube, Spotify, or Apple Podcasts to stay up to date with the latest in the bleeding edge in AI.